Now the next kind of log solving is not so clearly seen that it's log solving because you do not start off with any log terms. Alright, so this is where I call it the log equation, but it's in a non-log form at the beginning. So when we look at this one, okay, we are asked to solve for x. So we have 6 to the power of x plus 2 equals to 21. Now we have learned in indices that if this is a number like for instance 36, we can actually make them the same base of 6. Then we can continue by equating the exponents. But 21, no matter how you try, cannot be put as 6 to the power of something. So this is where we cannot use the indices method and we have to use the log method. So anything that's floating up in the air as an exponent must be brought down by using log. So I always call this the rabbit, right? The power is like a rabbit. So if you don't put a log on both sides, the rabbit cannot jump down because without the log to help it, it will just die. Alright, so we're going to take log on both sides, and there are two kinds of log that you can use, either LG or LN. LG is base 10, LN is base E. So we have LG, it's also known as base 10, or LN, which is actually base E. Both can be used, but normally we'll use this one. Special cases we use this one. I'll show you in a short while. So let's just use LG. Alright, so I'm going to log the left hand side, and I'm going to take log on the right hand side as well. So once you have this, right, this is your power, right, the exponent. Using the power rule, you're going to bring it down. So if x plus 2 log 6 equals to log 21. So in other words, you're going to solve for x, right? So what you're going to do is that you're going to divide the log 6 out first. So we have x plus 2 equals to log 21 over log 6. And this can be evaluated using your calculator. But I'm just going to write it out this way so you can just do it all at one shot. So in order to solve for x, I'm going to have a minus 2. So I have log 21 over log 6. And the 2, when I bring over, is minus 2. Then you can just press it all at one go. And correct to 3SF when you press your calculator will be roughly around this. Now, how do you check whether it's correct? Very simple. Put this back into the original question here, and you check whether you can add up with close to 21. Alright, so this is where you use log on both sides, the log being base 10. Now for the second question here, alright, you see that this is an E. So because this is an E here, rather than using base 10, which is LG, let's use LN, which is base E. Alright, so I'm going to do the same thing here. So I'm going to take log on both sides, but I'm going to take the LN log, okay, the natural log. So same thing, 3x using the power rule, you bring it down. Okay, now don't forget LN, log E to base E is the same base. So this value here is actually the same as 1. So you have 3x times 1 equals to ln 9. So to solve for x, you will have ln 9 divided by 3. Now be careful, ln 9 over 3 is not the same as ln 9 over 3. They are not the same. So when you press your calculator, right, you have to press ln 9 first. Okay, so I'm going to show you. So ln 9. Okay, so ln 9, press the equal sign. So this is the value that you have. Alright, ln 9. Then you divide by 3 after that. Okay, so you'll be able to get it. Correct to 3SF will be roughly around 0.732.